Good day, everyone. Let's talk about the relationship between the differentiability and the continuity of a function. Thus, we have a topic: differentiability implies continuity. Differentiation is the word in which it means that it is the process of calculating a derivative. Again, to get the value of the derivative, we take the process through differentiation, not derivation. Let's take a review of the continuity of a function at a certain point. A function is continuous at a number c if all of the following conditions are satisfied. The f of c is defined, the limit of the function exists, and the limit of the function is equal to f of c. If at least one of these conditions is not satisfied, the function is said to be discontinuous at that point. For the continuity on a real number, a function f is said to be continuous everywhere if the function is continuous at every real number. And for the differentiability, a function is differentiable at a number c if the f prime of c, which is equal to the limit of f of c plus h minus f of c all over h as h approaches 0, exists. Let's take for an example the function the cube root of x. Is it continuous and differentiable at x is equal to 1 and x is equal to 0? Let's find out. Let's start with the continuity. At x is equal to 1, so our c here is equal to 1. So the f of c is equal to the cube root of x. So the f of c is f of 1, which is equal to the cube root of 1, which is equal to 1. This is our f of c. The second test of continuity, which is the limit of the function. So the limit of f of x as x approaches 1, with the limit of the cube root of x as x approaches 1 is the cube root of 1, which is equal to 1. Now we can see that the f of c and the limit of the function is equal. Therefore, it satisfies all the conditions to make the function continuous at a certain point. Therefore, the function is continuous at x is equal to 1. Next step is at x is equal to 0. So our c here is equal to 0. So let's start with the f of c. So the f of c is f of 0, so it becomes the cube root of 0, which is equal to 0. So the f of c is equal to 0. Next is the limit of the function. So the limit of cube root of x as x approaches 0, that's cube root of 0, which is equal to 0. So the limit of the function is equal to 0, which is also equal to the f of c. Therefore, again, satisfy all the three conditions of the continuity at a certain point. Therefore, the function is continuous at x is equal to 0. So both x at x is equal to 1 and at x is equal to 0, our function is continuous. How about the differentiability? Is it differentiable at x is equal to 1 and x is equal to 0? Let's find out. To know if our function is differentiable at x is equal to 1 and x is equal to 0, let's get the derivative of the function. Okay, so the function is cube root of x using the alternative definition of the derivative f prime of x is equal to the limit of f of x plus h minus f of x over h as h approaches 0. Okay, so the f of x plus h is the cube root of x plus h minus the f of x, which is the cube root of x all over h. Okay, so by direct substitution, as we plug the value of h with 0, we can see that the function is 0 over 0 in indeterminate form. So to get the real value of the limit, we need to factor the function or to rationalize this. So in this case, we need to to rationalize the function. We should multiply the numerator and the denominator of the conjugate number of the numerator in order to get the radical sign of our numerator here. So the cube root of x plus h minus the cube root of x, the conjugate number, is the cube root of x plus h squared plus the cube root of x plus h times x plus the cube root of x squared. We will multiply that both in the numerator and the denominator. So first term, the cube root of x plus h times the cube root of x plus h squared is equal to the cube root of x plus h quantity cube. The cube root of x plus h times the cube root of x plus h times x is equal to the cube root of x plus h quantity squared times x. The cube root of x plus h times the cube root of x squared is equal to the cube root of x plus h times x squared. Next, the second term, negative cube root of x times the cube root of x plus h squared is equal to negative cube root of x plus h squared times x. Negative cube root of x times the cube root of x plus h times x. That's cube root of x plus h x squared. Next, the negative cube root of x times the cube root of x squared is negative cube root of x cubed. Okay, for denominator, it's as is, h times the conjugate number. Okay, so let's simplify this. The cube root of x plus h squared times x minus the cube root of x plus h squared times x is equal to 0. This is also 0, so what remains here is the cube root of x plus h cubed, and take note we can see cube here, so we could cancel that. So what remains is x plus h. The next one is the cube root of x cubed. Can cancel that. What remains is the negative x. X minus x is 0. So h, divide h here, is equal to 1. Thus, 1 over the cube root of x plus h squared plus cube root of x plus h times x plus the cube root of x squared. Next is you plug in the value of 0 to all h. So, the result is 1 over the cube root of x squared plus cube root of x squared plus cube root of x squared. And the answer is 1 over 3 times the cube root of x squared. So this is the general expression of our derivative, and we will use that to plug in the value of 1 and 0 to get the derivative. So for the f prime of 1, that's x is equal to 1. So f prime of 1 is equal to 1 over the cube over 3 times the cube root of 1 squared. That's 1/3. If our x is equal to 0, so the f prime of 0 is equal to 1 over 3 times the cube root of 0. That's 1 over 0, or that is math error or undefined. So the f prime of 0 is undefined. So we could conclude that the function is differentiable at x is equal to 1 because the value of the derivative is 1/3, while it is not differentiable at x is equal to 0 because the f prime of 0 is undefined. You can verify that through the graph that at x is equal to 1, our function is differentiable and continuous because there is a slope of a tangent line at x is equal to 1, while at x is equal to 0, you can see that this is continuous, but you can see a vertical tangent line. According to our lesson previously, that there is no slope in the vertical tangent line. Thus, there is no derivative at x is equal to 0, and in this case, at x is equal to 0, it is not differentiable.